Okay, um, so today we're going to talk about Leetcode 9A6. The title is Interval List Intersections. I think this question is generally difficult if you're a beginner of Leetcode because it's not very easy to think about a solution yourself. You might take a while to think how to approach this question. So here we are going to use 2 pointers to solve this question. One pointer point to list A, and the other pointer point to list B. So what's this question talking about? It is given one array, one list A, and A has all the intervals, something like 0 to and 5, 10, so on and so forth. So let's visualize it. A will look like this. This is 0, 2, and here's B. Let's say 1 to 2. And therefore, B is 1 to 5 actually, 1 to 5. So the intersection between 0 to 2 and 1 to 5 is 1 to 2. So this is their intersection. Okay, and how do we solve? So what do we provide is that we need to return a list of all the intersections, and it is worth noting that the equal part also be the intersection. For example, as you see at the result here, the second output is 5 by 5 5, so it is just one value. There is no intersect. 5 5 itself is an intersection. Okay, so let's start to code for this. Okay, at first I personally like to define the length for each list, and let's call NA is equal to length of A, and B is the length of B. Let's call result equal to empty list. And now we have to go through each arrays, both list. So we have to define a pointer for each list. Now we started for the while loop. While I is smaller than an A and or ij smaller or smaller than MB, then let's analyze it. So what should we do now? So we might need to compare which value is bigger, which value is smaller, right? So in this case, the result 1, 2, where's the 1 came from? one is came from B, right? Because B is the beginning of B is larger than the beginning of A, and where's the 2 came from? It actually came from A, because the endpoint of A is smaller than the end of B. So let's do star equal to star is the bigger one. So let's try to max A. And it is the beginning, right? It's the beginning. And B is also the beginning. At this point, we get 1, right? The max of AI is 0, and the max of BJ 0. Yep, that's 1. And the end is min of AI1, BJ1. So here we got 2. Okay. So now we have start and end. And how do we know it has intersection? And in this case, star is smaller than n, and that's how they have intersection. For example, if you have some B like this, the start is here, right? And the end is here. The star is bigger than n, and therefore there is no intersection. So they only have intersection when star is smaller or equal to n, right? If star is smaller or equal to n, what should we do? We put it in the result. What does it look like? Star n. And okay, so now we can update it, right? But now we have to, after updated the first result, we need to move on the pointers. And how do we move on the pointers is we need to find out when should we move I and when should we move J. And in this case, if let's say I is here and J is here and J is down here, when do we have to move I? Is that when when the end position of A is smaller than the end position of B, then we definitely know there is no intersection anymore. For example, if we have a like this, and there might be another list here. So in this case, we only record the result for this part, but we still need to record the result of this part. So we shouldn't move I, so we should move J, right? And that's what I mean. When the end position is smaller than each other, we should move on. Okay. If the A of I 1, of course we can write in another round. I mean, like we can compare B smaller than A as well. B J 1, then we move on ji, else we move j. This looks better. Okay, I think that's all of the, oh wait, we haven't returned anything. We have to return the result. Okay, let's try to run through the test cases. We get an A, compare result is empty, I is initialized to 0, j is initialized to 0, while that get start and end, and we compare them by the start and end. If it's smaller or equal, we will append the result, and we move on to updating the I and j. Okay, let's try to submit it. This index out of range. Why is it out of range? What is out of range? Max. Out of range. Print I, j. How many elements is that? 1, 2, 3, 4. Oh, you use 4. Okay. So because I shouldn't use and, right? I mean, I shouldn't use or, because there's no point if one of them already done. Because if one already done, there's definitely no intersection afterwards. So I think so we should change to n. Let's try to analyze its time complexity and also its space complexity. For the time complexity, because we use 2 pointers and we only go through those list once, so it's O(n). For the space complexity, let me think. Do we try to allocate by anything? So we only use 2 pointers for the space. Get 2. We only need to record a start and end point, right? So we didn't allocate more resource for that. So it's basically O(1). Okay, and that's all. This is the solution. We try 2 pointers, and the trick is we use the information from start and end point to update result. And compare its endpoint to know whether which one should move on. Okay, that's it.